Okay, so in this lesson, we're going to look at solving rational equations, and these rational equations will be reducible to quadratic equations. So in a previous lesson, we did solve rational equations, but those equations were reducible or they led to linear equations. In these examples, the rational equations will lead to quadratic equations. Now let's remind ourselves what rational equations are. So a rational equation, remember, contains rational expressions. And a rational expression is a fraction with a polynomial in the numerator and the denominator. So here's an example of a rational equation. So notice that each of those terms, and it doesn't have to be all of them, at least one. So a rational equation contains at least one rational expression. But in this case, if you look at each of those terms, you have fractions: 2/3, 4/5, 1/2, right? And over here, in the second one, same thing. You have at least one term with fractions. And some people will think of 4 as 4 divided by 1 as well. But when students think of rational equations, what comes to mind is an equation where you have a rational expression, at least one of them, that contains a variable in the denominator. See, these rational equations did not contain variables in the denominator. This one does. And that's what students think of when they think of rational equations. But these are rational equations as well. They just don't have variables in the denominator. In particular, if you think about it, we can also call this rational equation a linear equation. So that's a linear equation as well, because notice it has x to the first and your denominators are all constants. And over here, in this particular rational equations, this could be considered a quadratic equation. So that's a quadratic equation. And the reason is because you see an x squared, right? The largest exponent is 2. Here's an x. It doesn't have to have an x to be quadratic. It doesn't have to have an x term, but you do need an x squared. And the denominators are all constants. But this one you have to call a rational equation. So that is what students think of when they hear the word a rational equation. So it's an equation where you have at least one rational expression with a variable in the denominator. That's what students think of when they think of rational equations. But remember, these are also called rational equations as well. So let's go ahead and start looking at some examples where we're going to solve rational equations. So let's look at the first one. So here's the first one. Okay, so the first equation is x plus 6 divided by x equals -5. And in all the examples we're going to look at, you are going to have at least one rational expression containing a variable in the denominator. So you have this rational equation. And we want to solve this rational equation. So let's remind ourselves about the steps to solving a rational equation. So the first thing you're going to do is you're going to find the least common denominator of all your rational expressions in the equation. So if you look at all of the rational expressions, this denominator is a 1, this denominator is a 1, but you see an x here. And when finding the least common denominator, you need to make sure that your denominators are factored. Now, this is a monomial, so there's not anything else I need to do with this. So my least common denominator will be x. Okay? Now, the next thing you got to do is you got to determine your restrictions. Because remember, we are dealing with a rational, in this particular case here, we are dealing with a rational expression that contains a variable in the denominator. So you have to find the values of x that makes this rational expression undefined. Okay, so recall, what makes this rational expression undefined is when that denominator is 0. So if I'm going to find the restrictions, I got to look to see where is this denominator that contains a variable, where is that equal to 0? And all you do, if you recall from the previous lessons where we reduced to linear equations, you just set that equal to 0. And so right away, x is by itself, so my restrictions is that x cannot equal 0. Okay, so there's your restrictions. X equals 0. X equals 0 makes the makes one of the rational expressions undefined. Okay, so it makes one of the rational expressions undefined. Okay, so my restriction at x and I equals 0. Okay, so let's go ahead and now go to step 2. So that was step 1. You need to find your LCD and then determine the restrictions. Step 2. We're going to multiply both sides by the LCD. Remember the reason for that. The reason for multiplying both sides by the LCD is to clear the fractions. So my LCD is x, right? So I'm going to go ahead and rewrite this over. I get x plus 6 divided by x equal -5. So multiply both sides by x. What you do to the left, you do to the right. And then we're going to solve the resulting equation. So to solve the resulting equation, I'm going to go ahead and use the distributive property. And then I get x times x is x squared plus x times 6 divided by x, right? Just like this, equal, and then this is -5x. Reducing x times x divided by, 6 divided by x, the x's divide out. I'm going to go ahead and rewrite this over just to show you. So I just rewrote that equation over. And so these x's divide out. And so I get x squared plus 1 times 6 is 6 equal -5x. All right, so that's where I'm at. So notice I went from a rational equation, and then notice this equation here. This equation is quadratic. I don't have any variables in the denominator any longer. So I went from a rational equation to a quadratic equation. So that's what we're talking about here when we say solve rational equations, and these will lead to quadratic equations. And so now I just have to solve this quadratic equation. So let's go ahead and put this in standard form. So I'm going to add 5x to both sides, and let's go ahead and put this in descending order. I get x squared plus 5x plus 6 equals 0. And this one's factorable, so let's go ahead and factor this. If it wasn't factorable, we'd have to use the quadratic formula, but it is factorable. So when I factor this, I get x plus 3 times x plus 2 equals 0. And then setting each factor equal to 0 using the zero factor property, I get x plus 3 equals 0, x plus 2 equals 0. And so solving each of those linear equations, I get x to be -3 and x to be -2. Okay? Now, remember at the beginning, you had to determine what value of x makes any of these rational expressions undefined. So my only restriction was x cannot equal 0. So if I did all this correct, which I did, if I did all this correct, then the final step, before you say those are solutions, so right now we're going to think of these as our proposed solutions. So think of these as proposed solutions. All right, so these right here, those x equal -3 and x equal 2, those are solutions to this quadratic equation right here. But the question is, are they solutions to the rational equation? That's where the restrictions come in. So all you got to do is, number 4, verify that the solutions is or are not restricted. So I have 2 proposed solutions, and none of them are restrictions. The only restriction is that x cannot equal 0. So these proposed solutions are actual solutions. So we're going to say since x equal -3 and x equal -2 are not restrictions, the solutions are x equal -3 and x equal -2. All right, and so those are your solutions. So there's the work. You have to show the work, and there's your solutions. All right, so that's number 1. So it's not difficult at all. It's very similar to the ones where you solved rational equations that led to linear, except this time when you multiply both sides by the LCD, we're going to end up with a quadratic equation. Okay, so now let's look at number 2. Number 2. Okay, so number 2, we have this rational equation. It looks complicated, but remember what, like we said, as long as you follow the steps, you should be fine. But notice that these rational expressions, each of those rational expressions, all three of them, contain variables in the denominator. So step 1, remember step 1 is to, if I can find our sheet. So step 1, remember, is to find the least common denominator. And so to find the least common denominator, first thing you have to do is make sure that those denominators are in factored form. And all of these are linear factors. And so, and the GCF of each one is 1. So there's, in terms of factoring first, there's nothing I need to do. So all I got to do now is remember, when finding the least common denominator, the least common denominator is a product of all of the factors that you see in the denominators. So this factor is x minus 1 is going to be one of my factors in the denominator. This factor is x plus 1 is going to be one of the factors in my least common denominator. So far, my least common denominator is x minus 1 times x plus 1. And this factor is x plus 1, which I already have it. So don't list it again, because then it no longer becomes a least. You want to find the least common denominator. Okay, the least common denominator. So I already have this as a factor, so don't list it again. So my least common denominator contains two factors, x minus 1, x plus 1. And now we're going to find the restrictions. The restrictions are easy to find. They're very easy to find. So just look at your denominator and determine what makes this denominator 0. So basically, you're just going to set each of those factors in the denominator is equal to 0, and you solve for x. So this rational expression here will be undefined when x minus 1 equals 0. So that's going to occur when x equals 1. So my restriction is that x cannot equal 1. The other one, x plus 1 equals 0. So this rational expression is going to be undefined when x plus 1 equals 0, and that occurs when x equals negative 1. So there's another restriction. X cannot equal negative 1. This rational expression is undefined when that denominator is 0, which I already talked about. That's a restriction. So there are only two restrictions, 1 and negative 1. All right? So now let's go to step 2. So step 2 is to multiply both sides by the least common denominator. So you're going to clear your fractions. So I'm going to go ahead and rewrite this over. I'm going to put that here a little bit further down, since I have some space here that's written on. So I have my least common denominator, which is x minus 1 times x plus 1 times the left side. So it'll look like this. 1 over x minus 1 minus 2x over x plus 1. So I'm multiplying both sides by the least common denominator. So this side, I'm putting in parentheses or brackets, and this will be multiplied by the LCD. Okay, equal. Now on this side, since I only have one rational expression, I'm not going to put it in parentheses like I did this one. So I'm just going to write like this, and I'm going to say times the LCD, x minus 1, x plus 1. Okay? All right, now the next step is to, in this case, to get rid of the brackets here. So I'm going to go ahead and distribute. And when I distribute, I get the LCD. Remember, this is LCD times that first rational expression. So it looks like this, x minus 1 times x plus 1 times 1 over x minus 1 minus, and then the LCD times this. So x minus 1 times x plus 1 times 2x over x plus 1 equal. And I'm going to go ahead and rewrite this over. 2 divided by x plus 1 times x minus 1 times x plus 1. So once you get to that point, remember the whole purpose of multiplying by the LCD is to clear your denominators, clear your fractions. So you want these denominators to now be a factor of 1. And they will now, because look, the x minus 1s divide out. X minus 1 divided by x minus 1 is 1. Same thing here. The x plus 1s divide out. And over here, the x plus 1s divide out. All right, so remember the whole purpose of multiplying by the LCD is to clear those denominators. Get those to be factors of 1s. So now I have 1 times x plus 1 times 1. That's easy. 1 times x plus 1 times 1 is x plus 1. Minus, see this minus right here, right? So minus, now be careful here. That's x minus 1 times 2x. So you have a binomial times 1, which is that binomial, right? And then x minus 1 times 2x. So let's put that monomial in front of the 2x minus 1. So that'll be 2x times x minus 1. So by doing that, it's going to help us to easily distribute. Equal, and then here you get 2 times x minus 1 times 1, which is just 2 times x minus 1. Okay. So notice I went from a rational equation to an equation with no fractions. This is quadratic though, because if I distribute, I get an x squared. So I get x plus 1. A negative 2x times x is a negative 2x squared. A negative 2x times a negative 1 is a positive 2x. Equal, and distributing here, I get 2 times x is 2x. 2 times negative 1 is a negative 2. Okay? So again, notice I have this quadratic equation. Combining like terms, I have a negative 2x squared. X and a positive 2x is a positive 3x, right? And then plus 1. Equal, and then 2x minus 2. All right, so I'm going to go ahead and rewrite this quadratic equation in standard form. So let me go ahead and subtract 2x from both sides. And notice I'm aligning my like term. And I'm also going to add 2 to both sides, just like this. So I did 2 steps in one. So you're going to subtract 2x from both sides and then add 2 to both sides. And remember, the whole purpose is to get 0 on this side, standard form. You want 0 on this side. So I get negative 2x squared. 3x and a negative 2x is a positive x. 2 and 1 is 3, equal, and then this is 0, right? So 0 right here. Now here's the problem. So many students have trouble. This is going to be factorable. You don't have to use quadratic formula here. This is going to be factorable. But when it's factorable, many students have trouble when that x squared term has a negative coefficient. So let's go ahead and I'm going to go ahead to make that a positive coefficient. You can multiply both sides by negative 1. So I'm going to go ahead and multiply by negative 1 to make the x squared term positive. Okay? 0 times negative 1. What you do to the right, what you do to the left, you do to the right. Now go ahead and distribute the negative 1. I get a negative 1 times a negative 2x squared is a positive 2x squared. A negative 1 times x is a negative x. A negative 1 times 3 is a negative 3, equal, and 0 times negative 1 is 0. And now notice this is a lot easier to factor. A lot easier to factor. So notice what happens though. So what happens when you change, when you want to make the x squared term a different sign, you're going to multiply every term by negative 1 on both sides. Notice that's the signs that these terms are opposites. Negative 2x squared, positive 2x squared. Positive x, negative x. Positive 3, negative 3. 0, 0. Okay? Now this is factorable, so let's go ahead and this is easier to factor, so let's go ahead and factor this. So you get 2x, x, this is going to be 1, this is going to be 3, and I need this to be negative, this to be positive. Okay, so now setting each of those factors equal to 0, I get 2x minus 3 equals 0, x plus 1 equals 0, and then we're going to solve each of those linear equations, and when I do that, I get x to be 3 halves here, and over here, I get x to be negative 1. So these are your proposed solutions, right? So these are your proposed solutions. But remember, you have to check to see if these proposed solutions are solutions to the original equation. You see, these proposed solutions are solutions to this quadratic equation. See, each of these quadratic equations, these are solutions. These are the solutions. But are they solutions to the rational equation? And that's where the restrictions come in. So look, my restrictions were 1 and negative 1. Positive 1, negative 1. What do you notice here? X equal negative 1 is a restriction. So since x equal negative 1 is a restriction, since x equal negative 1 is a restriction, the only solution is x equal 3 halves. So x equal 3/2 is the only solution. Okay? Now, just to remind you, so remember that this proposed solution right here, x equal -1, is not a solution to the original. Just remember, we say that x equal -1 is an extraneous solution. So x equal -1 is an extraneous solution. So remember, when we think of the word extraneous, we think of false. So x equal -1 is a solution to this quadratic equation, this quadratic equation, this quadratic equation, this quadratic equation, and this quadratic equation, but it's not a solution to the original. Okay? All right, so the only solution is 3/2. All right, so that's number 2. So be aware that you could end up with extraneous solutions, and if you did all this work correct, all you have to do is look to see what your restrictions are. Okay, so that was number 2. Let's look at number 3. Okay, so let's look at number 3. So number 3, we have this rational equation, and again, the first thing you have to do is find the least common denominator of all the rational expressions in the equation. So this denominator, that's a monomial. So my least, and there's, in terms of factoring, there's not anything you can do here. Same thing for x plus 2. So my least common denominator will be will include factors from each of those denominators. So this factors in x will be part of my LCD. This factors in x plus 2 will be part of the LCD. So remember, it's a product, so see multiplication, product of each factor that you see in the denominators. And this right here, if you think of 2, that's really 2 divided by 1. And so since that's a 1, we don't actually put it here. It's understood to be a 1. Okay, so there's your LCD. Now, the next thing you got to do, remember, is to find the restrictions. So the restrictions is you look at each of those factors that are in the denominators and ask yourself, what makes this denominator 0? Because you don't want that rational expression to be undefined. So this is just x. So what makes that 0 is when x is 0, right? So x cannot equal 0, because that will make this denominator 0, which makes this rational expression undefined. For that one, for this rational expression, look at your denominator and ask yourself, where is x plus 2 equal to 0? Well, x plus 2 is equal to 0 when x equals -2. So there's the other restriction. And then this right here, there's no variable in the denominator, so those are the only 2 factors you're going to look at to determine your restrictions. And so there are 2 restrictions, 0 and -2. So now let's go ahead and do step 2. So step 2, now we're going to multiply both sides by the LCD to clear the fractions. So let's go ahead and do that. So let me go ahead and rewrite this over. So I have 3 divided by x plus 4 divided by x plus 2 equal 2. So on the left side, I have 2 rational expressions. I'll put that in parentheses or brackets, and I'm going to multiply by the LCD, which is x times x plus 2. X times x plus 2. What I do to the left, I do to the right. Okay? Just like that. And then we're going to go ahead and solve that equation. So we're going to use the distributive property. And over here, remember, that's the LCD times that first rational expression. So x times x plus 2 times 3 divided by x plus the LCD, x times x plus 2 times 4 divided by x plus 2 equal. And over here, I can go ahead and distribute the 2x here. So that's 2x times x, which is 2x squared, and then 2x times 2, which is 4x. All right, so that's where I'm at. Now remember, the whole point of multiplying by the LCD is to get these denominators, to clear your fraction, to get these denominators to be factors of 1. So when I do that, I get that, because these x's now divide out. These x plus 2's, these factors of x plus 2's divide out. And so I have 1 times x plus 2 times 3. So I'm going to put the 3 in front. I get 3 times x plus 2. Plus, and then x times 1 times 4 is just 4x equal, and then 2x squared plus 4x. Okay? Still solving this. Now notice I went from a rational equation to a quadratic now. So they're no longer fractions. I see an x squared, so this is quadratic. So I'm going to go ahead and distribute to solve this a little bit further. So I get 3 times x is 3x, 3 times 2 is 6, plus 4x equal 2x squared plus 4x. Combining like terms on the left-hand side, I get 7x, 3x and 4x is 7x, plus 6 equal 2x squared plus 4x. All right, so I'm going to go ahead and put this quadratic equation in standard form. So since x squared has a positive coefficient and it's on the right-hand side, I'm going to go ahead and subtract 7x from both sides, just like this. And notice I'm aligning my like terms. And I'm also going to do the next step as well. So I'm going to subtract 6x from both sides, just like that. So 7x plus 6 and a negative 7x plus 6 is 0, equal 2x squared. 4x and a negative 7x is a negative 3x, and then minus 6, right? And so I have this quadratic equation in standard form, and I'm going to go ahead and transpose both sides, so that way the variable expression is on the left-hand side. So I get 2x squared minus 3x minus 6 equals 0. Okay, so now let's see if this is factorable. If it's not factorable, well, I'm going to have to use the quadratic formula. So in this case, in this problem here, some students will spend quite a few minutes determining how to factor this. But I just want you to remember something. So if you're having a little difficulty determining, let me rephrase it. If it's taking you a little too long to factor this, look and see if it's factorable. So a quadratic expression will be factorable if, when you look at the discriminant, so remember the discriminant, oops, nt, the discriminant, so remember the discriminant is b squared minus 4ac. So if you look at the discriminant, in this case, a is 2, remember a is the coefficient of x squared, b is the coefficient of x, which is negative 3, and c is your constant, which is negative 6. So remember your quadratic equation, ax squared plus bx plus c equals 0. All right, so the coefficient of x squared is a, the coefficient of x is b, and your constant c. All right, and then if you substitute those numbers into the discriminant here, let's see what we get. So b is negative 3, so you get negative 3 squared minus 4 times a, which is 2, times c, which is negative 6, right? So I get negative 3 squared is 9. A negative 2 is, negative 4 times 2 is a negative 8, and a negative 8 times 6 is a positive 48. And when I add these together, I get 57. Now notice 57 is not a perfect square. So since 57 is not a perfect square, 2x squared minus 3x minus 6 is not factorable. Not factorable. Can we write this better? F-A-C-T-O-R-A-B-L-E. So it's not factorable. So I had to use quadratic formula. So that's one way. Rather than spending 2, 3, 4 minutes trying to factor this, you may want to right away see, well, is it factorable? And that's where you look at the discriminant. So b squared minus 4ac, the discriminant. And make sure you do the discriminant correct. So that's 57. 57 is not a perfect square, so I'm going to have to use the quadratic formula. So let's use the quadratic formula. So quadratic formula is this. Remember the quadratic formula. So my variable is x, so your quadratic formula is the opposite of b plus or minus the square root of the discriminant. That's what we just found here, right? b squared minus 4ac. So b squared minus 4ac, all divided by 2a. So I'm just going to go back and substitute all these numbers into those variables. And so I get x equal the opposite of b. Well, b is a negative 3. The opposite of negative 3 is a positive 3. plus or minus the square root of b squared minus 4ac. And by the way, we already found it, right? So you could just put 57 here if you want to, square root of 57. But I'm going to go ahead and actually put all the steps in when using quadratic formula. So since b is negative, put that in parentheses. That's important. Negative 3 squared, right? Put negative 3 in parentheses since b is negative, because b squared can never be negative, so be careful. Minus 4 times a is 2, times c, which is negative 6, all divided by 2 times a, and a is 2. Equal 3 plus or minus the square root of negative 3 squared is 9. A negative 2 times a negative 6 is a positive 48. And that should look familiar, right? From here. 9 plus 48, that's what you see here. All divided by 4. So that's 3 plus or minus the square root of 57 divided by 4. And the square root of 57 we cannot simplify, so there's the answer. So notice there are two solutions, right? So remember that, two solutions. So and by the way, the restrictions are 0 and negative 2. This is not 0, and this is not negative 2 either. So the solutions are 3, x equal 3, plus the square root of 57 over 4, x equal 3 minus the square root of 57 over 4. So those are your two solutions. And if you want to write it in as a compact form like this, that's fine. Or you can say x equal 3 plus or minus square root of 57 over 4. Okay? All right, so notice in this example, I had to use the quadratic formula. And so remember, these two solutions here are irrational. Those are irrational. That's why we had to use the quadratic formula. It was not factorable. So when we did the previous example, I just want to remind you, when we did the previous example, our solutions, well, in this case, there's only one solution, but our proposed solutions, you had two proposed solutions, and those were both rational. This is an irrational number. Square root of 57 is irrational, which makes all of this irrational. Okay? Let's do one more. Just to make sure you got the process. Okay, so now in this rational equation, notice that this denominator, this linear factor, is prime. I cannot factor that any further. This one's prime, but I can factor this one, right? So when I factor this quadratic polynomial right here, I can factor this as x minus 4, x minus 3. Okay? And so when we go through the process, you're going to notice I'm going to leave this rational expression with this denominator to help us. If you leave it in factor form, it does help. So let's go ahead, since I factored the denominators, so let's go ahead and find the LCD. So my LCD has to include every factor that you see. I see an x minus 4, I must use it. I see an x minus 3, I must use it. I see an x minus 4, I already have it. Don't list it again, because then it's no longer a least common denominator, and it'll make this whole process so convoluted you're going to have difficulty. Only use the least common denominator. And the next one is x minus 3, which I already have. So my least common denominator is the product of, is this product right here, x minus 4 times x minus 3. Okay? Now let's find the restrictions. So the restrictions, remember, are the values of the variable that makes each of those rational expressions undefined. So what makes those rational expressions defined is when the denominator is 0. All you do is just look at your denominators. So I have an x minus 4. Where's that 0? Well, x minus 4 is 0 when x is 4, right? So there's one of my restrictions. X cannot equal 4. Over here, x minus 3. Where's that 0? Well, x minus 3 is 0 when x is 3. So there's another restriction. This one, x minus 4, I already talked about it, so I already have it. X minus 3, I've already discussed, I already have the restriction. So there's only 2 restrictions. Okay, so now we're going to go to our next step, which is to multiply, step 2, which is to multiply both sides by the least common denominator. So we go ahead and rewrite this over. So I have 3x over x minus 4 equal, and remember this is the one that contains 2 rational expressions on one side. So I'm going to put some space here, and I'm going to do this. So 2x divided by x minus 3 plus, and when you rewrite it, when you rewrite this rational expression here, leave it in factored form because you're going to be using the LCD, and the LCD is in factored form. So 6 divided by x minus 4 times x minus 3. Okay? And I'm going to multiply both sides by the LCD, so I get x minus 4 times x minus 3. X minus 4 times x minus 3, just like that. Okay, so now we're going to go ahead and solve this equation. So we're going to go ahead and distribute here. And we'll go ahead and leave this alone for right now. So I get x minus 4 times x minus 3 times 3x divided by x minus 4 equal. And then the LCD times this rational expression, x minus 4, x minus 3 times 2x divided by x minus 3 plus, and then x minus 4 times x minus 3 times the second rational expression, 6 divided by x minus 4, x minus 3. Okay, so now remember the whole purpose of multiplying both sides by the least common denominator is to get these denominators to be factors of 1s. And now we're going to reduce. So the x minus 4's divide out, the x minus 3's divide out, and then these 2 factors divide out as well. So you're left with factors of 1s in their places. So I get 1 times x minus 3 times 3x. So I'm going to go ahead and rewrite this as 3x times x minus 3 equal x minus 4 times 1 times 2x. So I'm going to rewrite this as 2x times x minus 4 plus, and then 1 times 6 is 6. Okay, now notice I went from a rational equation to a quadratic equation. So you know this is quadratic because if you distribute on both sides, you're going to get a polynomial expression where the largest exponent is 2. So I have 3x times x is 3x squared. 3x times a negative 3 is a negative 9x equal. 2x times x is 2x squared. 2x times a negative 4 is a negative 8x. And then plus 6, right? Okay, so the next step is to combine like terms, which I cannot. So now I'm going to go ahead and rewrite this quadratic equation in standard form. So I'm going to go ahead and bring the terms to the left-hand side so I can make x squared have a positive coefficient. So the only way I can get x squared to be a positive coefficient is to bring the terms to the left-hand side. So I'm going to subtract 2x squared from both sides, just like this. I'm going to do a bunch of steps at once. So the next step is to add 8x. Notice I'm combining like terms, right? And then the last step is to subtract 6 from both sides. Okay? So now let's combine like terms. When I combine like terms, 3x squared and a negative 2x squared is a positive x squared. A negative 9x plus 8x is a negative x, and then minus 6 equal, and all this is 0. And now this is factorable. So it's easy to see that's factorable, right? All right, so let's go ahead and factor this. So it'll be x minus 3, x plus 2 equals 0. And then I'm going to set each of those factors equal to 0. So I get x minus 3 equals 0, x plus 2 equals 0. And so x minus 3 is 0 when x is 3. X plus 2 is 0 when x is negative 2. So these are the proposed solutions. Remember that. Proposed solutions. So notice, though, that these are solutions to this quadratic equation, or to any of these quadratic equations that I have. But the question is, are these 2 proposed solutions a solution to the rational equation? All right. It could be that one of these could be extraneous. Could be a false solution. So that's where you look at your restrictions. So my restrictions are 4 and 3. What do you notice right here? Yep. So So this right here is an extraneous solution. Extraneous solution. It's a restriction, right? X equal 3 is a restriction. So you're going to say the only solution is x equal negative 2. Okay, that's the only solution. All right, and that's 4 problems we looked at in terms of solving rational equations. So it's not a very difficult process, is it? It's very similar to solving a rational equation that we did a month ago or so, where it was reducible to linear. These were reducible to quadratic. But the steps were the same. All the steps were the same when solving these rational equations, just like you did in the past. All right, so that is the end of this lesson.